Good morning and a warm welcome to my session. Today it's all about Kubernetes in Azure, so-called Azure Kubernetes Services. My name is Marc Müller. I'm a consultant at Fortecture in Switzerland, and we are focusing on everything around DevOps, Azure DevOps, and modern business applications in the cloud. And this is why I'm here. I'd like to present you a full journey to Azure Kubernetes Service, which means we're going from zero to hero. We are building it from scratch, and I'll try to answer all the questions you need to know, how to start, how to set it up. During my session, if you have any questions, there is a chat available, directly a live chat in YouTube. There is also a Discord channel, and I will be available there as well after my session. If you have any further question, I'm happy to answer them. So let's have a quick look at the agenda for today. So I'm presenting a quick intro about Kubernetes, what it is. Then we are doing an overview about AKS, and then we are doing the full setup. And then we are also discussing how to deploy the application, how it is going on. I will be using Azure DevOps for it, and you will also see it at the beginning in the demos, how we actually deploy applications. And then in the end, we'll do a short recap and answer some questions. Okay, so let's start with the introduction. So for all of you who never heard of Kubernetes, I don't believe it, but it could be. So Kubernetes is an open source system for automating the deployment, scaling, and management of container-based applications. So basically, if you need a platform to deploy your Docker container, containerized applications to, Kubernetes is the way to go. And this is what we're having a look at today. Okay, so where does the name comes from? So it's a Greek word for helmsman. So this is why we have a lot of analogies to ships, to sailing, etc. So all the project names have to do something like this. And this is because of the name itself, because it relates to helmsman. So Kubernetes, or also called K8S, because there are 8 characters between K and S. It's a little bit shorter. It was originally developed by Google, so it was the Google data center basically, but then handed over to the Cloud Native Computing Foundation, and it's now present in all the large public clouds, and it's also used on-prem as well. So it supports a number of container tools, including Docker. So it won't support Docker in the future, but there is no problem. A lot of people were afraid by the latest announcement that they skipped Docker support, and Docker is still OCI compliant, so Open Container Initiative compliant. So a Docker container which is built by you on your machine can still be run on Kubernetes, even though they're not supporting Docker in the future anymore. And yeah, orchestration using Kubernetes, as I already told you, is supported by all the leading cloud platforms, including Azure, Bluemix, Red Hat, OpenShift, AWS, etc. So it's really the most common platform for containerized applications. But today, we will focus on Azure for sure. And one last warning. I will show you some demo. And yes, it's a demo. Sometimes it's a little bit too simplified. So for a Hello World application, you normally don't need a big cluster setup, but it's the goal is clear. I want to show you the concepts, even though the applications are quite small. We are going to deploy to Kubernetes today. So what we are going to set up is the following. So we have our Azure DevOps running, hosting our application code, hosting the build pipelines, etc., to build and deploy our applications. And then we have this big thing over here, which is basically our AKS we are going to build. This one consists of a master node, which is fully managed in Kubernetes. I will come to that in a second. And we have the agent nodes, which are backed up by Azure VMs, running the actual workload of our cluster. And before that, we have the Azure Load Balancer or an application gateway to basically handle the incoming traffic and then distribute it to the nodes and the pods and the containers inside. So this is what we are going to build. We are also using some additional tooling. For example, we are using a cert manager to automatically generate, maintain, manage our certificates. You will see it in a second in the first demo. So basically, if we deploy a new app with a new URL, we have the cert manager running, requesting the certificates, do the whole certificate request, storing it as a secret, and then provide it as a TLS certificate for all the future calls. From the workflow perspective or point of view, what we normally do is we build an app, then we test it, we build the container. So our CI produces a container image, and that image will be pushed to a container registry. We are also creating some configuration. We are using here Helm charts, which is more or less a package consisting of a lot of Kubernetes manifests together with a templating engine to switch some values to do some configuration during deployment. And then during the release, we are tokenizing this configuration, like putting the right URL in for dev, test, and prod. We have different URLs, we have different connection strings, and so on. And then finally, we're pushing that configuration to Kubernetes, to AKS in this case, and it's a desired state configuration. So then Kubernetes is analyzing it and then is pulling the latest image, the image we referenced in the configuration, and then runs our application as specified in our manifests. So yeah, then let's start. I quickly go full screen now for a first demo. So I'd like to show you how we use actually Kubernetes, or what you could achieve with it. So first of all, we want to create or deploy an application package. So an application consists, as I already told you, out of a Docker image or a container image, to be general. And then we have a configuration, a manifest on how to configure it. And in the first demo, we do exactly that. We are just deploying a hello world to Kubernetes. So this is our Kubernetes. And on my local disk, I have this chart folder, which is the full configuration. And I've got also the values file. So this is an override file to actually show or tell the Kubernetes cluster what to use. So we have this hello world image. We have a dedicated URL we want to deploy to. We want to have TLS certificates. So this is the kind of things we are going to configure. Then I'm running the Helm command. And now, after I executed it, we can again go back to Kubernetes. And here you see this is starting up. You see the deployment, you see the pods, and you have this special pod here. So this is an automation we're actually using to generate the new certificate, to create a certificate request for us in order to have TLS encryption. So if you access now the page, you see a privacy error coming up. This is due to the fact that we didn't have any certificate. It is currently created by this special pod in the background. And as soon as we get it back, it's a matter of seconds normally. So if you refresh, here we go. We have a fully deployed application with a fully featured certificate. Here we are using Let's Encrypt Go for generating it. And there it is. So within seconds, we were able to deploy our application packaged as an image together with a configuration to our platform. And the configure platform did everything else. So the ingress configuration, the traffic from the outside, the host URL mapping, the certificate generation and management, everything was done by our platform. So next thing we want to achieve is we want to have load balanced services. So as you can see here, I've got another demo application, a greeter service, an API, which is just sending hello worlds, basically. and we have 3 instances of it, and they are distributed across our nodes. So they are distributed here across the different node pools. So if we run that, we have a load balancer in front of it. So it's a so-called service. So we have the public load balancer in front of it. This is forwarding it to a service. And if we access it, we will be redirected to one of those instances. Technically, this is a round robin currently implemented. So I printed out here the node or the container ID. And you will also see those pod IDs over here. And every time I'm accessing the server, you will notice here that it changes. So every time within this round robin, we actually access a dedicated instance. And to visualize that, I created a quick CLI application, which is just polling this application and gets the greetings from different instances. So we will use that in a second to show you more benefits of Kubernetes, to again complete the picture of how we could use it and then understand what we need to set up to go there. So we have this load balance service, but actually it would be nice if we could have or achieve a zero downtime deployment. So in a modern world, we want to have a deployment process where every change, like I did a feature branch, created a PR, the PR was accepted, and I could directly publish that to the production. So if I do that, and if I do that multiple times a day, we should be able to achieve a zero downtime, because otherwise you're still blocked. You need to check with your customers, etc. So we don't want to do that. So one of the benefits out of the box is a rolling update. So if you use the Kubernetes deployments, it automatically supports a rolling update mechanism, which means that, for example, here we have 4 pods running. And if we run a new deployment, that one pod after each other, it's configurable, by the way, will be updated. So it goes through, we can define how many pods can be removed, how many pods can be added to achieve this rolling update. And there is still all the new running, and your customer doesn't even notice that you're doing a deployment in the background. And so you're enabled to run multiple deployments a day. So let's have this quickly in a demo. So this is my greeter controller, and I'm going to change here the message. So we have here a message property, and I'm just changing this string, recompiling the thing, and I'm deploying it again to my cluster. So let's quickly do this commit. Then we can switch over to our pipelines. We will see that this commit has triggered a CI build. So here we see the new version, and my CI build consists of a CI stage and a deploy stage, or 2 different jobs. So first of all, we need to rebuild the application because I changed the code. So I need to recompile it. I need to create a new container image, upload the container image to the container registry, create the Helm package, which could also be updated, and then I'm deploying it. So currently we are just compiling. On the right-hand side, you see my shell script up and running, and we will need that to see that it's really a zero downtime deployment. So in the background, the pipeline itself is pretty easy. Most of the code resides in the Docker file, where we define how to compile and build it. And it really just calls Docker build, Docker push, and then creates a Helm package out of it. So CI is now finished. So the next stage is executed. We're now going into this deployment stage. And here we are downloading the created artifacts and are upgrading it. So now on the right-hand side, you should see that one is now gone. It's the red one, which is gone. So I allowed it to delete one of them. We still have 2. In the background, they are now starting up the new ones. So here we have a new one. We see demo v2. So we have a mix of all the new containers running. The pipeline is finished, and Kubernetes now runs with 3 instances of the new demo v2 instance. So this is how we achieve the zero downtime deployment. And again, it's more or less all out of the box, and you get those features with the standard Kubernetes configuration. Okay, then we want to scale a little bit. So I'm quickly starting that demo. What do we do here? So we do the same thing. I quickly change the background processing of my greeter application to calculate prime numbers that we actually get high CPU usage. So let's trigger that one. So now you see that we have those prime numbers being calculated just to get more CPU usage. And here, this is the view of the horizontal pod autoscaler. We defined it with having maximum 10 replicas, minimum 3. And we see the current CPU utilization percentage because this is the limit. Every time it reaches 50% or more, I'm creating a new instance out of it. So in the meantime, I'm increasing the load on my command line and polling the API over and over, generating not only this hello message, but also calculating the prime number. And the more clients I'm opening, the CPU should actually raise up, and then we should see the auto scaling. So this is a dedicated configuration. It's not out of the box. I mean, the functionality is out of the box, but you have to specify it. And you also have to specify the metrics. So CPU is a very, very simple one, to be honest. So here we see the update. You have 59% CPU usage. And here we see that desired replicas was 4, current was 3, and now it's 4. So in the background, it created a new container instance, a new pod instance to scale up in my cluster to get a better performance better performance. So we are again stressing it a little bit to just see it raising again. So keep an eye on those numbers here to see that it is going to scale. So in the reality, only using CPU or RAM is not always the best thing to scale. Maybe you'll have some decent metrics like a customer response time, or you're monitoring other key indexes of your system to get the best feeling when you need to scale. So basically, the pod autoscaler is just there and says, oh, if this value is over threshold, I'm creating new one. So here we see again, it's now 4 and 6. So we have we want to have 6, and in the background, it just created those new containers, and now we're running with 6 instances out of the box. I didn't have to do anything, so this is fully automated in the cluster. Last but not least, before we go on how to create it, is the last demo. We want to go passwordless. So normally, if you have to deal with passwords, it's not a good thing because they can get lost. You need to have secret management again, but it's as you know, if we wouldn't have any passwords at all, our life would get a lot easier. So what I want to show you here is I've got another sample application. It's a developer jokes application. So it has a front end, which provides you the jokes, which is communicating with the backend, and the backend obviously accesses the database. So here we got the backend pods, and this is just reading random jokes out of a database. So how did we do this database connection? If you have a quick look here, we see here the connection string, and you won't notice any password at all. So we're running it in a Linux container in Kubernetes in Azure, and we don't have any password specified. The database itself has a user, which is an Azure managed identity. So only with this managed identity, I can access the database. If we go to the resource group where my Kubernetes is deployed, we can see that I also created this managed identity. Here we have it, the dev1 prod. And we want to use that identity from our pods. So we need to somehow link it. We need to have an interceptor in Kubernetes to actually request a token in the name of this managed identity and then use it for accessing the database. So here you can see we have those 2 objects. We have a a binding, an Azure ID binding and an Azure identity, a managed identity. And basically, we just link those two. So we have a logical name for our identity, and we have a selector, which means I'm looking for pods running in my Kubernetes with this selector, and then I'm associating this managed identity with it. So here we have the Azure specific, so it's a client ID and the resource ID. This is the name, and this is actually what ID we are using during runtime. So at the end, what I need to do in my cluster is I need to associate it. So this is done by a simple selector. You see here this label, AAD pod ID binding, and this is enough during my deployment to tell Kubernetes and the pod identity extension to map those two things and request all the tokens based on this identity. In the background, you see here we have a couple of pods running. So it's an extension, AAD pod identity extension running in the background as a daemon, which is basically managing the deployment, sees what applications are there, do we have any binding defined, and then provides this interception logic of providing the right tokens to the right pod instance in your cluster. So a great thing we can achieve, and therefore we also need AAD integration for sure. And now we are going to look at how this all works and how we set it up. Okay, so quick overview of Kubernetes that we understand also how Azure Kubernetes Service is working. So in a normal cluster, you have master nodes controlling the whole cluster, and then we have the actual worker nodes, which run more than that, but the main work is inside the pods. So if you have a container instance, it looks like it gets wrapped inside a pod. The pod has all the network connectivity and has some resource limitations, etc. So this is basically wrapping the actual container instance. And if you're talking about an instance of a container, we're referring to a pod, because normally it's the case that we have one pod running one container, even though you could run multiple containers inside a pod, but there were so like helping containers for intercepting, proxying, etc. So one app instance is always one pod instance, to make it simple. Inside the master, we have a database. There, it's basically a key value store, the cluster store. We have the controller manager, a scheduler, and of course the API service if you want to deploy something, get some information. We are using this API server with our command line tooling or other tools as well. So inside the node, we have the kubelet, which is actually the agent running the whole thing. We have the cAdvisor, which is there for controlling the resources, how many CPU, RAM, etc. you're getting for your instance. We have the networking proxy, and then we have the container manager running those pods. So as you have already seen it, I'm really going quickly through it. So what features do you get? So it's all about automatic placement of containers. It's self-healing. We have health probes, running new instances, deleting unhealthy instances, etc. We can scale horizontally, which you already seen. We have service discovery and load balancing, as shown in the second demo, rollouts and rollbacks, the deployments. We have secret and configuration management with it. We have container storage orchestration, so we can write to a persistent storage as well. We can do batch execution, etc., etc. So now, what's the special thing about Azure? So Azure is also providing you a Kubernetes service, but they do it in a managed way. The cool thing is the complicated parts are now managed by Azure for you. So you don't have to deal with those nasty little things. The whole control plane is fully managed for you. You don't have to do anything with it. The only thing you manage, and you also pay for it, is the nodes. So you will end up having virtual machine scale sets running your workload. This is what you manage. This is what you scale, where you send the update commands, etc. And the rest of it is fully managed for you, and you only pay for the right-hand side. The left-hand side, the Azure Managed Control Plane, is free of charge. So you really just pay for your virtual machines. Good. What else do we have? We have the Azure Virtual Network interface. We will see it in a second. So we can connect to any Azure Virtual Network and set up our network infrastructure as well. And we also have access to Azure Disk and Azure Files. So if we need to store data persistently, we can just create a persistent volume claim. Say, I need 10 gigabytes of data, and the managed Kubernetes service creates your Azure Disk or your Azure file in background and mounts it into your container, and it's just there, your persistent storage. So this is a really cool integrations, and you don't have to worry about those low-level things anymore. So what it is, as a short recap, it's really making it simple for you to deploy a managed cluster in Azure. It reduces the complexity dramatically, and all the critical tasks about health monitoring, maintenance, etc., is already done for you. You can basically just use a cluster. For sure, you have some smaller application level related maintenance, but the big bare metal thing is just away from you, and you just use this service. Okay, so how about the security? One cool thing is that if you're using Azure, we can use the Azure infrastructure for security. So AKS supports role-based access control, RBAC. This is how the normal Kubernetes is working, but you can join it with Azure AD. So the cool thing is, if you have Azure AD groups, like those are my developers, those are my infrastructure administrators, you can easily use those existing groups in Azure AD and then provide the role-based access control inside Kubernetes and get them access to a dedicated namespace or some actions, etc. So then the nodes, as I already told you, it's just virtual machines. If you scale them up, they are automatically deployed and added to the cluster for you, etc. So it's just a virtual machine scale set with some base images managed by Microsoft. So you can also run Windows Server if you would like to. To be honest, on a production environment, we never did that so far. So we are normally using the Linux virtual machines for those. Yeah, so we can also do an auto scaling. You have seen the pod scaling, but we can also do a cluster node scaling. So if you're running out of resources in our existing VM, we can automatically increase the VM count and scale up without changing any configuration. It's just doing it automatically. So there are also GPU nodes. This is important if you do some GPU-related calculation, etc. Those are also available. You just have to choose the right VM size or VM type. Okay, so yeah, it will cost a couple of bucks for sure. Again, you only pay for the VMs. So it's basically just the VM pricing, like here 3 VM instances. It's about 310 Swiss franc for smaller VMs. And if you want to have uptime SLA, you also need to pay for it. And then that's all. For sure, if you need additional disk, you have to pay for the storage and you have to pay for the bandwidth. But again, it's mainly just the VM you have to worry about. And the rest is the same thing as with any other Azure pricing if you're hosting a service. Okay, so long story short, now we want to see how to set up. First thing we need to talk about is there are a couple of different network configurations. And logically, it's quite simple. We have a client application accessing a service in our Kubernetes cluster. So it somehow gets to an Azure load balancer. This one is forwarding it to a so-called ingress controller, a controller inside the Kubernetes cluster, which has all the configuration, how to do the SSL termination, how to forward it to an internal service, which is doing this round robin, keep track of the rolling updates, etc. And then it is basically load balancing to all the pod instances for you. But there are two different ways you can achieve that. So there is one configuration approach, which is called the basic networking. And this is also called KubeNet. And the big difference here, and this is also the default, is that it uses network, the net features. So as you can see that if you have a node subnet where all your VMs are put in, we have a dedicated address range for the pod instances, and there is a routing net controller in between dealing with it. So on the other hand, we can use Azure CNI, which is also called advanced networking. And the big difference here is you place your pods directly in the same subnet. So if you have a subnet here, where everything, where your whole cluster resides, you see that they're using the same address space. So every pod, every instance of a container of your application gets a dedicated IP address within your subnet, which means that you can directly access also the pods inside your network, and you don't have this net in between. So of course, you're using more IP addresses of your subnet, but if you have a dedicated subnet, this isn't a problem. You can scale out more with this option. So you can have more instances with that. So now the question is, when do I need what? And let me quickly go over here to make it simple. If you use an application gateway for the public traffic, and we will cover that in a second, you need to use the CNI, this advanced networking mode, because otherwise the application gateway won't work directly accessing your pods. On the other hand, if you want to use this managed identity feature, it is strongly recommended. Technically, it would be possible with the KubeNet, but it is not recommended because of security reasons that a token could be hijacked. So long story short, if you either use application gateway or managed identities for authentication, go with the advanced option. And if not, you're free to use KubeNet, but you could also use the advanced options without using the two above. So again, if you're talking about this whole network connectivity, it is important to see that we have two ways of doing it. One way could be that all external traffic is sent to an application gateway. Application gateway is an Azure service which handles all the gateway functionality of incoming traffic and routing it to an instance like here, a pod. The cool thing here is this one resides outside, and it's also the reason why we need this advanced networking, because all the routing, load balancing, health check is done here in the application gateway, and the requests are sent directly to the pods inside your Kubernetes services. This is cool because you basically gain more free resources inside your cluster, because you don't need to run this whole SSL termination, routing, etc. It's outside in a dedicated service, and therefore it's a quite cool option you get with AKS and application gateway in Azure. On the other hand, and I base my current demo on this one, is to have an ingress controller inside your cluster. So we are running here an Nginx ingress controller inside. I have the full control of what I'm doing inside the cluster. I have no external dependencies. So I have directly the Azure load balancer sending the traffic to a couple of pods doing this load balancing ingress thing, the ingress controller, and then forwarding it to the individual pods. So it's basically about having the compute and networking inside or outside your cluster, and this is the decision you have to make. If you go to the app gateway, the website, they will say, yeah, it's a lot better because it's everything outside your cluster. You have more CPU, more network, etc. available for doing so. But in reality, to be honest, we had some problems. So the changes, if you do a rolling update, etc., are propagated too slow to this application gateway, and we had to downgrade the speed of the updates, etc., to achieve that without having a loss of connectivity. So in the end, I personally prefer still the in-cluster load balancer because it's just more flexible, you have more features, and it's way faster for configuration changes. Not the networking itself, but if you add new pods, add new services, delete services, this is a thing didn't achieve the application gateway in a way that we didn't have to slow down the upgrade processes inside Kubernetes services. Okay, so then let's have a quick look on the AAD integration. I just have seen a question from the YouTube chat from Olaf. What is the minimum number of KAS nodes necessary for running containers high available? Yeah, so the thing is, it's at least 2, because if one node fails, you need to be able to route the traffic to the other one. So you need at least 2. Normally we start with 3, that we have 1 more, even though if you're doing updates of your nodes, etc. So normally we have 3 and more nodes running in AKS, but you need at least to have 2 node instances to have at least a failover if something happens on a node for you. Okay, then AAD integration. So basically, we want to connect our cluster to AAD and use it for authentication, role-based access control inside the cluster, and also use the managed identity features to actually authenticate the pod with for accessing external services as well. Good. So, for example, here you see also that we have some service principles created. So if you do the AAD integration, you will notice that applications are created inside your Azure AD, which represents the cluster itself. So you can also set permissions for those service principles. And you also see, for example, here we are using managed identities for the node pools. So everything which is related, which is done by a node, is using this managed identity. And now you're in normal Azure permission set. You can just set permission for those identities or service principles to act inside your Azure environment and let them create resources, access resources, etc. So it's pretty straightforward once you connected it. So what normally managed identities do we use? So we use the kubelet, so the agent pool itself, to have some special permissions. Then if you use the application gateway, you will have a dedicated identity for doing so. And the thing you've seen in the last demo, if you want to, for example, authenticate against your Azure SQL database, you will need this AAD pod identity, which is also using custom or specific application-specific managed identities to acquire the token and then authenticate it. Okay, so basically this AAD pod identity is acting like an interceptor. We are creating a binding to a pod, and then whenever this pod is trying to access some resource, it creates a token, this one, or requests a token. It is basically intercepted by those daemons. Then it is acquired from Azure. The token is sent back to the pod, and then the pod accesses the resource based on that access token, and you can really get rid of any passwords at all inside your cluster if you're just using managed identity enabled services in Azure. Okay, so let's see, how do we do that actually? So normally we set up an infrastructure as code pipeline. So it's a Azure DevOps pipeline which runs a lot of Azure CLI scripts. Normally we are doing that in PowerShell. You could also use Bicep or ARM templates, etc. So the only important thing is that you're using configuration as code, and then we set up a pipeline with it. So this one is creating the AKS cluster, container registry, SQL Server infrastructure. Everything we need in this case for our demo is set up by this infrastructure pipeline. So how does it look like? So first of all, if you want to set up AKS, you need a resource group for sure. This is pretty straightforward, and you have to know, and this is the only thing you need to know about Kubernetes in Azure. If you set up a Kubernetes AKS instance, it creates another managed resource group for you. So here you have the logical services placed in AKS demo, and then you see this MC AKS demo, blah, blah, blah. This is where the actual generated resources are going in. So it's like the VMs in your scale set, the load balancer, the managed identities, etc. So they all go into that additional dedicated managed resource group for you. Then we need a container registry. You can use your own already existing one. You can create another one, but at least we need during runtime a container registry where we can pull our Docker images. So this is the Azure one. You can also export all the logins. You could also do managed identity access to it. So it's basically generate or create a container registry because we need one after that one. Good. Then VNets. We talked about the networking. So normally we use the CNI version, the advanced networking mode. And so we need, first of all, create a VNet. Normally we create a quite large one. It's a /8 one. And then inside this VNet, we are creating a subnet, a /16 one, for placing the Kubernetes. So all the pods with all the nodes with their pods, etc., will be placed in this 16 subnet we created here. So we need to create them and then, of course, provide them during cluster creation. And yeah, we can export the subnet IDs, etc., because we need them later on. If you use application gateway, so if you want to go that way, we need also a dedicated subnet for the application gateway. So in the same VNet, we just create a second subnet for the application gateway resources, do basically the same thing, export the IDs, etc., that we can set it up correctly. And of course, if you're doing that, we also create a public IP that we can use as a public entry point in our application gateway and cluster later on. Great. Okay. So if you use the application gateway, you have to create it in advance, or at least you need to have an instance that which can be linked to the cluster manager if you want to do so. So it's also pretty straightforward. AC network application gateway create. You have the capacity, SKU, etc., some settings, and so on. You assign the IP address you just created, assign the VName, VNets, etc., subnets. It's a pretty straightforward thing to create, and then we have the application gateway running. Again, it's not necessary. You can also use those in-cluster ingress controllers. So then we are finally creating the cluster. So it's on Azure CLI, it's AKS create. We use our created resource group. Then now that the managed resource group, this technical one, will be created with this command. We tell which networking plugin we want to use. So we set up the VNets, etc. We want to use the advanced networking. We enable AAD integration. We also define our managed management security group. So we created a dedicated group in our Azure AD for all the cluster admins that they have admin rights. Then we set up the tenant. We provide a Kubernetes version, so the initial version. You can then later on upgrade your Kubernetes instance through the management UI in the Azure portal or by CLI. Then we define the node VM size. So you could also have many node pools. So you can have CPU optimized node pools. You can have memory optimized node pools. You could have GPU optimized node pools and run them side by side. And during your deployment, you could define a node affinity to say, okay, this application needs to go to this pool. This application goes to this pool. But here, with a starting point, you create one node pool with a defined VM size and a disk size to be created initially. Then we can define what do we want to have. So here we want to have a virtual machine scale set. We need to use a load balancer in a standard SKU. We have the VNet we created so far, some service internal networking stuff. So we can define an internal DNS prefix. Then the cluster autoscaler, we can say, okay, what do we need? Min max count of the nodes. So you can automatically scale your cluster and you don't have to sit next to it and scale it manually. You could also have a private cluster. For the demo, I didn't do that, but normally in production environment, you don't want to have public APIs. So you want to have your APIs only available in your VNet. You connect through a VPN to your VNet, and then you can access your clusters. So normally, for a productive environment, you want to have a private cluster without opening the management interface to the public. Okay. Great. Then we need to set a couple of permissions. So if you want to use, for example, the managed identity feature, you need to make sure that this node pool managed identity, where the nodes run on, they need access to this resource group with a virtual machine contributor permission and a managed identity operator. If you don't provide that, you are not able to do this managed identity authentication because they cannot be read, cannot be assigned, etc. So this is an important thing to know. It's somewhere buried in the documentation that you need to set those permission as well. Same thing if you use App Gateway, it also uses a dedicated managed identity. So you need to set up here also for both resource groups, for the logical and the managed one, you need to provide access to it. And here we define a contributor permission for application gateway to access everything and set up the routing, etc. Okay, and then you have your cluster. So there it is. This is the Azure portal, and it's all set up and can be used from now. So it's a couple of CLI commands to actually set it up, and then it's up and running. So here you also see this generated resource group. And here we see all the details. So we see the public IPs, we see the load balancer, we see the different disks of our node pools, we see the managed identities and the node pool itself. And if we dig in, I created a cluster with 3 nodes, and here you see those VMs running in the virtual machine scale set for our cluster. Okay, so autoscaler, we already enabled it. I quickly have to have a look at the time. So we have about 3 minutes left. So what else is important to set it up? As I already told you, we have, for example, this group, the Kube administrators group in our Azure Active Directory. And we can simply use that with this AAD integration to create a cluster role binding with our cluster admin role and use this Azure AD group. So every member of the Azure AD group will automatically have this, for example, cluster admin permission. And you can use it for developers and whatsoever. So whatever you do, define your groups in Azure AD and map them to the role-based access control inside the Kubernetes service. So a couple of things to install. We need the pod identity, and I will quickly go through it. You will get the slides later on. So it's basically all available by Helm packages. So if you want to do this pod identity, just run the Helm package, and there you go. Same for Cert Manager. It's basically installing a Helm package, a couple of settings, you're good to go. And what else do we need? If you use the application gateway, then you need to have an application gateway ingress controller. It's also backed up by a Helm repository, and you can simply install it. Here you have to do a couple of more settings. So all the different settings where I am, which application gateway I'm using, etc., which identity, etc. So it's a couple of settings, but nothing really complicated. If you don't use application gateway, we're using, for example, Nginx. This is also available by a Helm repository. And here, just to note, if depending on your applications, you really need to set those buffer sizes. So if you use Nginx controller in a default settings, you normally end up with a couple of problems because the buffer size is too low, and then you have some strange errors. So keep in mind that if you're using Nginx and, for example, .NET Core services, you need to extend those buffer sizes to work correctly. Okay, so let me quickly check. So custom cluster config, normally we do set up the permissions, etc. So we also create a dedicated Helm package and then do that. So basically, it's all about creating default namespaces, then do the cluster role binding based on our AD groups, etc. to set it up. And of course, we also need to set up certificate issuer to have this fully managed cert manager running. Here you can see we can either use cluster issuer, here using Let's Encrypt. And this is really all you need to do for this automatic certificate generation, nothing more. Okay, and then finally, everything is set up and we need to connect to it. And here you can also use the Azure CLI. So you can say AC, AKS, get credentials. You're authenticating through Azure AD. You will get the kube control configuration on your machine, and then you can access your cluster also from command line, the Azure portal, or my personal favorite is Octant. It's a third-party tool, which is a view on top of the command line, which visualizes you the whole cluster. You can dig into all the settings, see what's going on instead of doing all by command line. Okay, last but not least, and then I will finish. We have a public API either in Application Gateway or through our Azure Load Balancer. So what you need to do is you need to set up your DNS configuration to that IP address, and then you're good to go. This is the Application Gateway, and if you use an Nginx ingress, you have a public external IP address in your cluster, and you just set this as an A record inside your DNS provider. So I'm already 1 minute over. Let me do a quick recap, and then I will be available also in Discord for some for more questions. So what have we seen? We have a managed Kubernetes, so it's an easy setup. The software upgrades are fully managed by Microsoft. We have an automated node scaling, which is possible. We only pay for the worker nodes and with a pay-as-you-go model. We have the full Azure integration. So we have the AAD authentication. We have automated integration of resources like networking, storage, etc. We can use Application Gateway directly integrated into our cluster if we want to use that together with a web application firewall. And for sure, we get all the Kubernetes benefits of scaling, load balancing, failovering, zero-downtime deployment, and so on and so on. So yeah, that's all I wanted to show. Thanks all for coming. Hope you enjoyed the session. Again, I'm here. I'm available in Discord for any questions because we are now running out of time. I'm already 3 minutes late. I'm sorry for that. Have a nice day and see you soon. Bye.